Okay, so welcome to Probability and Statistics. Today we're going to go over the total probability rule. Total probability rule. Probability rule. So what we have are these conditions. So the probability of A given B is equal to 0.2. The probability of A given not B is equal to 0.3. The probability of B is equal to 0.8. So we have these series of probabilities. So there's no real direct way or state space we can use to just go, oh, the probability of A, it's going to be this. So we have to kind of work around it a little bit. Now, if we are looking for the probability of A, normally what you would do if you have a set of probabilities is go the probability of A intersected with B plus the probability of A intersected with B not. So this would normally be what you were doing if you were looking for the probability of A. But since we don't have the probability of these, don't have any one of these intersections, we can't really figure it out. And you can't figure it out just from these numbers what those intersections will be. So we have to take it another step further and use the probability rule, where you take this and it is equal to the probability of A given B times the probability of B plus the probability of A given B naught times the probability of B naught. And these are all values that we can get because this one is given to us, this one is given to us, this one is given to us, and this one is just the flip side of what was given to us. So if you're, before I really calculate this, I wanted you to notice a pattern here. If you're looking for the probability of A within one of these, this is actually based on the one of the equations that is introduced earlier in the chapter. This is probability of A given B is equal to so on and so forth. That kind of thing. So this comes from something earlier in the book. But you can see how if you're looking for the probability of A is the leading variable, and B, the other variable, is the one that flips back and forth between B and B naught. The same is down here. A is the leading variable, and you're using given B times given B naught, and B naught B and probability of B naught. So you can see that if the one you're trying to find is going to be the leading probability inside this given parentheses bracket, and the rest of it is going to be the other variables, whatever they are. So this one becomes really easy now, and it just turns into 0.2 times 0.8 plus 0.3 times 0.02. Oops, 0.2. Get rid of that. I don't have a handy eraser. 0.2. And just add those up, and you end up with that equaling 0.22. And that is the probability of A, given that you have A given B naught, and B. So, pretty easy once you see that this formula is needed. And that's the biggest thing in statistics generally, is just to see which situation you have and what you can use.